This is a little demonstration showing chemical reactions. What I started off with was a strip of zinc metal, okay, and you can see, hopefully is it hot still? This zinc is kind of silvery, actually it's magnesium. Magnesium is silvery in nature, and as it burned, you can see what's left behind, and it is this white ashy material. Different properties from when we start off with this magnesium. So it produces lots of light, produces lots of heat. This is going to be section 5.1, looking at chemical reactions. And I first want to start off with what is called chemical equations. So I want to introduce some chemical equations to you that involve atoms and molecules and starting things and ending things. In this reaction, what we're starting off with is magnesium. Magnesium was that metal strip that produced loads of light. And when I ignited it, it was reacting with the oxygen. Okay, and so it was reacting with oxygen. And we're going to start to introduce some chemical symbols as well. And what it does is it produces, and I'm going to put this arrow like this, and this is an arrow that means it produces. Sometimes people will say it yields, it makes, produces, makes. And my end product is going to be called magnesium oxide. So this over here, these two things, my magnesium and my oxygen, these are called my reactants. It's because these are the things that are reacting. If you are a runner in a marathon and you are participating, you are a participant. These are the things that are reacting, so they are called the reactants. And they produce the magnesium oxide. And this is the end product, or it could be the products. Because you can sometimes start off with a single reactant and produce multiple products, or you can start off with multiple reactants and produce a single product. So my reactants, this is my starting stuff. So we'll just say it's the starting materials, it's the starting substance or starting substances. And my product, my end product, this is going to be the ending stuff. So what I'd like to do is I would like to show the chemical reaction in the form of a chemical equation, because we've used words, but I want to substitute now the symbols for these things. The symbol on the periodic table for magnesium is going to be Mg. I would like you to put a space in front of this Mg as well. And we're going to be adding to this, put a space right here, we're adding oxygen, and you might know that oxygen is not just O, but what we breathe is O2. So we have the magnesium, we have the oxygen. This is going to produce, we have the arrow going across, and this produces magnesium oxide. And the formula for magnesium oxide is MgO. Now, we're going to be getting into the concept of balancing equations in the next section, 5.2, but I want to introduce it right now because we've also seen this concept from a previous lab, and it's called the conservation of mass. The conservation of mass. Okay, and I think we've talked about this when we have an open system versus a closed system. This is where mass, just like matter, matter can neither be created nor destroyed. So with the conservation of mass, the mass in this reaction must stay the same. So the mass stays the same. And if the mass stays the same, that means the number of atoms that I have on the left-hand side of the equation should be equal to the number of atoms that I have on the right-hand side of the equation. I can't lose or gain atoms in this chemical reaction. Conservation of mass says that the mass must stay the same. So the number of atoms must stay the same as well. The number of atoms stays the same. So let's take a look at the number of magnesiums that we have. We have what's called a coefficient and a subscript. These numbers that are in the front here, these are going to be called the coefficients. We'll get to the coefficients in a little bit. We also have, like in O2, these little things are called subscripts. So the coefficients are in the front of the symbol, and the subscripts, they tell you the number of atoms that you have. How many O's do we have? We have 2. So let's take a look at the magnesiums. How many magnesiums do we have? We have, what's the symbol right there? Well, if we have H2O, the symbol for H2O, how many O's do you have in H2O? You actually have 1. Even though we don't say H2O1, we just say H2O. So how many magnesiums? Even though there's nothing there, there's an invisible 1. How many magnesiums do we have over here? We have 1. How many O's do we have here? We have 2 O's. How many do we have over here? We only have 1. So we just can't put a 2 right here to have it balanced. We have 1 magnesium, we have 1 magnesium. We have 2 oxygens, we have 1 oxygen. We can't just put a little 2 right here because that would be changing the chemical formula. And MgO2 actually cannot and does not exist. So what has to happen is this needs to create 2 molecules of the MgO. So that's what the space in the front is. So now I have 2 MgOs. So what I really have is I have MgO and MgO. We can put that here. I have an MgO and I have an MgO. So I have 2 of them. Here's the first one, here's the second one. How many Mgs do I now have? I have 2. How many O's do I have? I have 2. It's sort of like the distributive property in mathematics. I have 2 of these now, and I have 2 of those. Well, how many O's do I have on this side? I have 2 O's. So I don't need to put any numbers right here because I just need my 1 O2. Since I have 2 O's, one of the O's goes here, the other goes right here. But I also have 2 Mgs now, and since I have 2 Mgs, I have to have 2 Mgs over here. But I can't change by putting a 2 here. I have to do by changing the coefficient, by saying that I have 2 Mgs. So I have an Mg and an Mg plus an O2. So I have 2 Mgs, I have 2 O's. That's going to give me 2 Mgs and 2 O's. Now this is all balanced. So there's the first example of this. And I'm going to do another demonstration for you guys. And we're going to go over this balancing again and these the coefficients versus the subscripts. Okay, so there's more information that is coming. So what you see here is I have a container, and it is filled with some water. And I have a battery right here as well, and the battery is connected to these 2 wires. So I have these copper strips that I'm going to place, and I'm going to put them on the inside of the water, and hopefully you'll be able to see this and what's going to be happening. okay, you should be able to see the bubbles being produced by this reaction. So I'm going to take this copper strip out. The bubbles then stop. So what's happening in here? Well, what's happening is I'm taking water, so we're going to start off with water. So we're going to also have another chemical equation right here. So we have H2O, and let's put a space in front of this. This is just one thing that I'm starting off with. So this is my reactant. Remember I said you can either have multiple things and have reactants, or sometimes you can have a reactant which breaks apart into smaller products. What's happening is the bubbles that you're seeing are a combination of hydrogen, and it's also a combination of, what other atom do you see that's over here that's not accounted for over here? It's the O. And so hydrogen is H2, oxygen is O2. Now let's see if this is balanced. Again, here's my spaces for my coefficients. And my coefficients here, what they tell me, again, here's the coefficient is right there. The coefficients tell me the number of molecules that I have. And what we see here is these are our subscripts, this 2 and this 2 right there. 2 is also a subscript here. What's the subscript for the O again? The subscript is an invisible 1. So these numbers that are below are called the subscripts. Okay, sub means below, like a subway. It goes under the street, or a submarine goes under the water. So these are my subscript. Script means to write. So these are my symbols that are written. These are the numbers that go below the symbols. And the subscripts tell you the number of atoms. So over here, I had 2 magnesiums. Here I have 2 magnesium oxides. Here, since there's nothing there, I have 1 oxygen, 1 O2. In this case, the O2 is the only thing that has the subscript. Here, the H2O, I'm starting off with H2O. The 2 is a subscript, the 1 is a subscript. The 2 and the 2 are the subscripts as well. So we're going to try to now balance this. How many H's do I have on the left-hand side? Hopefully you're looking at the subscript and you're saying that I have 2. How many H's do I have on the right-hand side? You look at the subscript and it tells you I now have 2. How many O's do I have on the left-hand side? You should be saying to yourself, I have 1. How many O's do I have on the right-hand side? You should be saying that I have 2. So while my H's are balanced, my O's are not balanced. 2 here, 1 here, and 2 here. Everything needs to be balanced. So since my H's are balanced, what I have to do is I have to get my O's balanced. I can't put just a little 2 right here, because that would change the symbol from H2O, which is water, to H2O2, which is hydrogen peroxide. When balancing equations, I'm going to be using these coefficients. So we're going to, key concept, we're going to balance with what are called the coefficients. We can't change the subscripts at all. Okay, so let's go back. We have to balance my oxygen, so I have to change the number. How many O's do I need? I have 2 over here, I have 1 over here. I need to have 2 of them. Now remember, this is like the distributive property. Here I have 2 Mg's and 2 O's. Now I have 2 O's to match the 2 oxygens that are on this side. However, now I also have, how many H's do I have? I have 2 times 2, which gives me 4 H's. So previously I had 2 H's which were balanced, but in order to balance the oxygens, I had to unbalance the hydrogens. But now that I have 2 times 2 is 4, what number do I have to put here to make this equal to 4 hydrogens? And it would be looking like this. It would be 2 of these. 2 times 2 is 4. Let's take a look in terms of drawing these out and what they look like. H2O has a shape that looks like this. Here's my H2O. Okay, so we're going to go ahead and we're going to draw this. We have H2O. So I have H2O. Let's go ahead and draw my 2 H's right here from my H2. This is without the coefficients. Let's draw the O2 like this. Oxygen happens to have a double bond, and we will not be concerned with that in this class, but you will in the chemistry class. So I'm starting off with a water, and I'm starting off with 2 H's. I'm starting off with an O2. Again, we looked at my H's. I have 2 H's here. I have 2 H's here. I have 2 O's, so in order to get my 2 O's, I have to have 2 H2O's. I have to have H2O and H2O. Now, I have 1, 2, and 1, 2. But if I look now at my H's, I have 1, 2, 3, 4. 2 times 2 is 4. What do I need over here? I need another set of H's. 1, 2, 3, 4. 1, 2, 3, 4. 2 times 2 is 4. Now, we're going to do what's called atom counting, and we're going to be doing a lab on this. So this is going to be an introduction to the lab. So with this, we're going to rewrite this and going to be putting in some more information for this equation. So here's our balanced equation. We have 2 H2O's, and this produces 2 H2's plus O2. There's no coefficient in the front. This whole thing right here is called the chemical equation. That's the chemical equation. And what we have, we talked about having the coefficients and we talked about having the subscripts. These right here, these are called the chemical formulas. So again, we can't change the chemical formulas in order to balance. We have to balance by changing our coefficients. Because if we changed by adding a 2 here, we would no longer have water again. We would have H2O2. It's a different chemical formula, and it would mean it's a different molecule. So we can't change those. So what I'm going to do is we're going to count the number of atoms in each molecule. So we're going to be taking a look now at the water, H2O. Okay, here's my H2O. How many atoms do I have here? Here's my O, here's my 2 H's. I have 1, 2, 3. I have 3 atoms coming from my H2O. How many are in my H2? Well, if you look at the previous picture, we have our H2. How many atoms are in just H2? And that would give you 2. How many are in O2? Here's my O2. How many atoms do I have? 1, 2. So what we're going to do now is we're going to bring down the coefficients. I don't have, in this balanced reaction, okay, here it's 3 produces 2 plus 2. Well, that's not going to work because 3 does not produce 4. I can't start with 3 atoms and end with 4 atoms. Okay, that was our original equation. I actually need to now balance this with my coefficients. And if you remember, we had 2 of these, so I'm going to put this in parentheses. We also had 2 of these. going to put this in parentheses. So here's the coefficient coming down, here's the coefficient coming down. So the water has 3 atoms, the hydrogen has 2 atoms, the oxygen has 2 atoms. But we have 2 waters, so we multiply by 2. We have 2 hydrogens, so we multiply by 2. There's an invisible 1 right here, but if you multiply anything by 1, it's not going to change the value, so we're not going to spend the time doing that work. But now let's do the mathematics. 2 times 3 is 6. Produces, 2 times 2 is 4, plus 2. Bring this down, 6 produces, 4 plus 2 is 6. We've just shown the conservation of mass, where we again said that the number of atoms must stay the same. So we start with 6 atoms, we end with 6 atoms. We start with 2 waters that have 1, 2, 3, 4, 5, 6 atoms. We end up with 2 hydrogens, 1, 2, 3, 4, and 1 oxygen, 5, 6. That's the conclusion of this lecture.